So what is our goal? It's to raise awareness through education and outreach, to advocate for policy changes and develop new initiatives, to provide guidance, resource, and support for compliance with policies, and to advance firefighter cancer research through strategic partnerships, which is the partnership with UC Davis. There's a lot of opportunities that we can take advantage of if we choose to as an organization. In 2010, there was a study that was actually out of UC Davis, the epidemiology department specifically, and it was in partnership with the National Fire Administration and NIOSH. And what they did is they took 3 fire departments. It was San Francisco, Chicago, and Philadelphia, and they took their membership from 1950 to the early 2000s, and they did a survey, statistical analysis on them. And it was 30,000 firefighters was the cohort that they were looking at. And what they found was a higher incidence of cancer in firefighters versus the average population. 9% higher incidence of cancer. So a statistically significant increase in cancer risk over the average person. On top of that, what they found in that study was that if you had cancer as a firefighter, you were 14% more likely to die from that cancer. So 9% increase in getting cancer and a 14% increase in dying. And specifically, you'll see that there's like a 2 times risk for mesothelioma, a 2 times risk for cancer, testicular cancer, multiple myeloma, melanoma, prostate cancer, brain cancer, colon, leukemia, skin cancer. Those are all results that came out of that 2010 NIOSH study. The IARC, which is the International Agency for the Research on Cancer, convened a summit where they gathered 28 scientists from around the world to review all the studies that they could find on firefighter cancer incidence. And at the end of that international committee, they determined that we are a group 1 occupation. What does that mean? Well, IARC has 4 different groups. Group number 4 is not causing cancer at all. Group number 1 is we have evidence that this causes cancer. So kind of funny, but processed meats are considered a group 1, which is kind of an interesting thing. On ours occupation, we're considered a group 1, meaning that they have statistically linked our occupation to mesothelioma and bladder cancer, and they've had modern evidence for colon, prostate, testicular, melanoma, non-Hodgkin's. So what does this mean? This means that we have strong statistical evidence that proves that that suggests that our occupation causes cancer. Why is it? What is it that's giving us that increased risk of cancer? It's all the occupational exposures that we have. So that means stress, sleep disruption, UV, particulate, asbestos, PFAS, metals, all that stuff. So on the right, you'll see a little glowing figure, and this has nothing to do with cancer. But what it is a study that is based upon particulate exposure entering the bloodstream. So when we're not wearing a mask inside of a structure fire during overhaul, there's particulate. And yeah, you have the carbon monoxide and you have the hydrogen cyanide and all the gases and stuff. But really the concern for me is particulate. So depending on the size of the particulate, so this is a 10 micron particulate, this is a 1 micron particulate. The 10 micron particulate is heavier, it goes in and hits kind of the wall of your bronchiole, versus the 1 micron particulate goes deep within your lungs, and it actually goes across the alveoli inside of your lung. Same thing back in medic school. If you're an old school medic, we used to push drugs down the tube because the drugs absorb into your lung tissue. Same thing happens with particulate. Only you're breathing in the byproducts of combustion. So in this study, what they did is they took radioactive isotopes and they attached them to dust particulate in something called, they call it a technogas. So they filled a space up with technogas and had 5 subjects breathe in various particulate levels from 100 micron to sub 1 micron particulate. They had them breathe it in, and then they had the person step in front of a gamma scope. So the gamma scope is basically reading the radiation production coming off of those technogas particles. So you'll see that there's large amounts of particulate in the lungs that are emitting the radiation. Where else do you see green on the picture? Everywhere, right? First off, no one put Technigas on anything else other than their lungs. It's actually going across and going systemic. But you do see it in the thyroid. You do see it in the stomach. You do see it in the bladder. This is not a cancer study at all. This is literally an American Heart Association dust exposure study. And what you're seeing is large amounts in the lung, but the stomach as well. Why? Because when you're breathing this shit in, it's going in your saliva. And what are you doing with your saliva? You're swallowing your saliva. It's going down your digestive tract, going in your stomach, and then it's sitting in your colon. Because the spit eventually goes down, everything goes down, settles in, and it goes into a piece of shit. That piece of shit is sitting in your colon for hours and hours and hours and hours, with the particulate sitting there in your colon wall. Same thing with your bladder. So when you're looking at these increased rates of cancer, right, you're looking at stuff like esophageal cancer, buccal and pharyngeal, kidney, that's a filter, right? Filtering out the stuff that's in your blood. Breast, intestine, large intestine, stomach, small intestine, lung, bladder, rectum. This line right here is the average cancer rate for a non-firefighters included. It's basically a population cancer rate. This is specific to the study of firefighters. So in the average population, that is your standard. As a firefighter, this is your increased risk over standard of all your cancers. So if you're thinking that it's a good idea to not wear a mask during overhaul, probably something to reconsider. We're talking about exposure. Exposure is frequency, duration, and concentration, right? So the frequency, how often are you getting exposed to it? The duration, how long are you being exposed to it? And the concentration, how much of the substance are you being exposed to? So those are all important factors to consider when you're being exposed to the carcinogens. The longer and the more frequent and the higher concentration, the more likely you are to have mutations, which could potentially cause cancer. So there's a process. If a person dies, it's considered a line of duty death. There's a criteria for submitting that to the IFF. But these other organizations like the NFPA and NIOSH and whatnot, that's not something that they're going to be tracking. So why does that matter? And why does presumption matter? And why does logging this and making sure that you have your presumption matter? Is because the PSOB Act is one of the reasons. The PSOB Act is an act that gives you and your family a benefit in the event that you die. So you get $50,000 from the federal government, and you also get, I think, free education for your kids. But if it's not considered a line of duty death, you don't get the PSOB Act. So it's important not only to log your stuff for your own reasons and to get your own coverage, but also for your family to make sure that you get your presumption in the event that you get terminal cancer. All right, so why is cancer under-recognized as a leading cause of firefighter line of duty death? It's because establishing strong statistical evidence for a causal relationship is difficult. Why is it difficult? Because cancer is multifactorial and complex, right? You saw all the different reasons why we get cancer. There's no, like, if you worked at a circuit board factory using benzene to clean circuit boards, and all of a sudden everyone around you has leukemia, and you have leukemia because you're sitting there benzene and toluene cleaning circuit boards, it's pretty fucking easy to tell what's causing your cancer. It's the material that you're using. For us, we go on all sorts of stuff. Structure fires, lack of sleep, hazmat incidents, whatever. It's not easy to track down what is causing cancer within us. The other thing that's an issue is latency period. So each different carcinogen has different latency periods. So for instance, mesothelioma caused by asbestos. Mesothelioma takes 30 years on average to get a diagnosis versus something like leukemia has roughly a 3-year turnaround. So leukemia diagnosis is going to be something in that 3-year period, mesothelioma in the 30, all the other exotic wild cancers that no one's seen or very few cases, they have no linkage between any of that stuff. They don't know what causes it. They don't know what the latency period is. So depending on the cancers, if it's a small number cancer, right, like the guy in Los Angeles, he had some weird neuroendocrine cancer in his jaw. And the doc's like, that neuroendocrine cancer is not linked to shit. And they had to fight it. And that's what it took 3 years, was fighting back and forth, going like, look, just because it's not something that we've seen before doesn't mean it didn't come from your job. The other one is unreliable metrics. So the California Cancer Registry, so any serious cancer meaning so skin cancer is not really considered put in the registry, and the other one is like cervical cancer. But if you have a serious cancer, your oncologist will put you on a cancer registry. During that time, they'll be taking information. What job do you have? What is your longest held job? So if you have 20 years as a grocery store clerk and 19 years as a firefighter, your longest held occupation will be considered a grocery store clerk. So the California Cancer Registry, it's kind of a shit variable occupation. So even with that, it's difficult for them to tie occupational cancers to the registry, just from that simple fact that it's the longest held occupation. The other thing is confounding variables, specifically a variable called the healthy worker effect, meaning that the average firefighter does not smoke. We're generally more physically fit and younger than the average population. So the healthy worker effect impacts the cancer incidence from the standpoint that we are on average healthier. So the other thing that it kind of does for us is it's less likely for a healthcare practitioner to want to consider that we even have cancer in the first place. So if you're going to the doctor as a 40-year-old and you're having abdominal pain, and their first thing on their mind is not thinking cancer. It's you're 40 years old, we'll work you up for something else. But the whole goal here is to increase the index of suspicion, because I think what's actually happening, the reason why we have that higher mortality rate, remember we talked about that 14% mortality rate, is I think that there, as a younger patient population and a healthier patient population, we're likely to push off getting seen by a doctor, and our doctors are less likely to diagnose and to do the scans and stuff necessary to find cancer. So that means that when our cancer is eventually found, it's probably at a later stage, which means you have a higher mortality rate. So not only are you more likely to get cancer, you're more likely to be ignored for your cancer and then have a later staging, which is going to impact your mortality.